My subject is water. And in particular, our relationship, our feelings vis-a-vis water. And just to start this, let me invite you for a little bit of free association. What images conjure up the word water? If we were to close our eyes and just to pay a little attention, what do you see? It's usually purity, life-sustaining aspects, transparency. Or for the more visually inclined, it's a pristine lake or a bubbly creek or a thirst-quenching spring. Okay, we got it. So let's just put it on the shelf now and use it as an anchor to descend to the more mundane relationship we have with water. We flush 4 to 10 times a day. Ever wondered where all this stuff goes? We have been digging trenches for centuries in the developed world. We build these pipelines, elaborate sewage networks to take the stuff. When I say stuff, it's the excrement, the waste, to take it off our streets. And we build these dungy, dark labyrinth beneath our cities, where we take this ugly, disgusting stuff out of sight, out of mind. To outside the cities, to these centralized wastewater treatment plants, where we treat it, and then we discharge it into the river. How many of you have been to one of these treatment plants? Anybody? Well, there are very good reasons you didn't go. These places are generally ugly, disgusting, and very, very smelly. But nevertheless, this is the state of the art, and this is the generally accepted standard. And this constitutes our as humans, a major element of our water cycle, the urban water cycle. The trouble is that this practice cannot really continue very long, because as we all know, the planet is becoming smaller and smaller, and more of us live on this planet. And particularly, the whole planet is becoming more and more urban. The urban population is increasing by 60 million people every year. Now that translates to more than a million people every week. More than a million people. This week, next week, the week after. There's lots of new people in cities. And everybody who arrives either by birth or by migration into the city wants to do exactly the same thing that you and I do, which is open the tap, take a shower, wash the dishes, mop the floor, and wash the dirty laundry. The trouble is there ain't enough water left. There are regions around the world where what is called the urban water scarcity is very, very severe. That means that all the aquifer has been totally depleted, and the rivers are running dry. There's not enough water left for the agriculture that are passed, alongside the rivers downstream. And as the officials are looking high and low in these regions for more water, they realize that the best, most reliable, most abundant source of water is actually in the wastewater treatment plants. So that means in these regions, which are very much increasing, you really have to recycle the water. That's the only thing you can do. But then if you have to recycle the water, it really doesn't make sense to take it all outside the cities, treat it over there, and then build all the infrastructure, the piping, and then operate it so that you can reuse it again. It's just not sustainable. A very important tenet of sustainability is that you treat the waste where you generate it. So where do we generate it? We generate it in the city. So what it means is that we have to build wastewater treatment plants in the city. So ladies and gentlemen, let me introduce our new neighbor. Of course, if I ask you, how close would you buy an apartment next to this thing? The answer is never a number. It's always as far as possible. This shows you It's worth to bring it into awareness, our relationship to our own water cycle. So this is not a sustainable solution, obviously, but it is a problem that needs a solution. So 15 years ago, I teamed up with an old childhood friend of mine who, besides being a creative artist, his name is István Kenyeres, who besides being a creative artist, he's also a chemical engineer and a biotechnologist all in one. And of course, I'm the architect. And we set out to create a new genre. A new genre, which is a combination of technology, nature, and architecture. Technology, because it needed to be vastly more efficient than what we have today. You can't have these big, huge plants, occupying city blocks, one after the other. And it, of course, had to be natural elements because we believed that there's a lot to learn from nature. And thirdly, it has to be architecture because you would want to live next door if we do a good job. So this is what we came up with. What you see here, this greenhouse is a wastewater treatment plant. Incidentally, it's called Organica, by the way. And this is what it looks inside. I'm going to explain to you how it works, but in order to do that, I have to explain to you how a traditional wastewater treatment plant works, and I can do that in 2 minutes flat. So, when you take the wastewater, by the time it reaches a wastewater treatment plant, it's nothing but dissolved organic matter. So no hard pieces, don't worry, it's all dissolved organic matter. And what they do in biological wastewater treatment, they put these into these large concrete tanks, and they put in a lot of hungry bacteria. Because if it's organic matter, these guys will eat it. And it's true. And, you give them air, just like in your home aquarium, because these little creatures need to breathe while they eat. So, and there are now, this technology is actually 100 years old, and by now we have mathematical formulae that tells you how many bacteria, how much time, how much it takes for them to eat all the stuff. And remember, they are all in suspension, they are all swimming, okay? And then after they are done, they move to another vessel, another big, what is called a clarifier, which is a very quiet place. So all these well-fed bacteria now, in a very still water, have the opportunity to settle down. At the end of this process, it takes a few hours, or maybe less. At the bottom of this clarifier, you have all these well-fed bacteria, and at the top, you have clean water. This is the essence of all biological treatment. So now you are experts. Okay? What do we do differently? What do we come up with? So we decided that in these systems, there are a relatively limited amount of species. Imagine it's only guys who are willing to swim all the time. That's one. And we know by experience that you can keep about 3 to 5 kilos of these guys in each cubic meter of reactor. And remember, our idea was you really needed to make this place much smaller in order to fit into the city. So what we do, we put what are called plant racks on top of these reactors, same kind of approach. And the roots of the plants dangle into the water about 1.5 meters. And the role of the plants is not to treat the water at all, but to provide a habitat for a lot of additional organisms, as many as 3,000 and more. So why is that? For one, the root system is extremely elaborate and has a tremendous surface area. And that means that now that you have this place in the water, now you can invite many more new creatures. So now you're not limited to your invitation goes out. It's not limited to the swimmers. Now you can invite creatures who like to hug. So they now cling on to the roots. And it turns out we can keep many more of them in the water if you do this approach. Unfortunately, the roots of the plant only go down 1.5 meters, and for technical reasons, these reactors have to be at least 4 or 5 meters deep. So we invented this artificial root system, if you want, so that we can fill the entire reactor with this habitat. Remember, I'm an architect. I think in real estate. So we just increased this population density, and we were indeed able to quadruple the amount of hungry little creatures in the reactors and also the diversity. So because now we have the clingers, not only the swimmers, now we have a lot more life, okay? Of course, if you can increase the density this much, you can make these treatment plants much smaller. And we arrange these in a series of reactors. And as the water flows from one tank to the other, the composition will change. In the beginning, as you can imagine, there's a lot of food, if you want to call that. And of course, there's a lot of ammonia. It's food. It's definitely food for others. And then, so in the beginning, you will have creatures who are adapted to that condition, and towards the end, you will have no food left. Of course, you need organisms who are adapted to that, who can filter a lot of water to get those few little morsels of food. And of course, here, you have sensors and dynamic mathematical modeling of the metabolic processes and control software. I'm just saying this because this looks extremely benign, but it's very, very, very high tech. And of course, once you arrange these in these reactors, then high-level organisms, remember there are thousands of them, the species, high-level of organisms will emerge. And of course, at the end, you will have fish as well. But these guys eat on each other, of course, just like anywhere in nature. This is an example of survival. Let's take a look at some of the characters in the play. So these little guys are the ones who are swimming around and building up their bodies from the dissolved organic matter. This guy, the next one, is a big guy who is attached to the root on the left-hand side of the picture. And it waits until the little guy shows up and finds its way into its mouth. Until, with a big gulp, the little guy becomes dissolved organic matter. Or the next one, which will gobble up the dirt on top of on the screen. We call it the vacuum cleaner. It's really a single-cell organism, but shows you that under the microscope, a whole universe exists that can help us if correctly cooperate. If we correctly cooperate. Well, this is an aquatic worm that, again, is looking for food, and you can see how it finds it and how the food, our dirt, makes its way down its digestive tract. So, and while all this National Geographic stuff is going on under the microscope, this is the top of the reactor. You are in a botanical garden. And this place not only looks like a botanical garden, but it actually smells like one. With all these flowers, depending on which season you are in. And now you can probably appreciate this is okay to have next door. In fact, this one, for example, is in France, and you can see it's in a historical city. And you can see the castle, beyond the glasses up there, the old castle. Of course, the moment you move these facilities into the cities, all of a sudden, you can, as an architect, you can start to have fun. Because now there are demands, architectural demands. You can't just have an industrial building if you are, on the main street. These are various sort of designs that we have come up with for different settings. The phenomena that you see here is very similar to what happened to the loo or to the outhouse 150 years ago. Today, people spend thousands of euros in the developed world for fixing up their bathroom, and then they're going out and showing to their friends, look what a nice renovation I did, and here's the toilet in the middle. You wouldn't have thought about this 150 years ago to show your friends the outhouse. But today, the same phenomena is happening with wastewater treatment. Wastewater treatment is coming to town. That's the phenomena. Here's one who has arrived at already. You can see through the glass, the residential buildings in the background. The three guys in the middle, I'm one of them, is standing on 6 meters of reactors that is teeming with life and doing the stuff for us. This one is in China, for example. You see the residential tower on the left, and the treatment plant on the right-hand side. From the other side of the street, this is what it looks like, with the office building across the street, with restaurants on the first floor. So you see how it's coming to town? Or this one is on a beach, also in China, with the visitor center on the right-hand side. Or this one is actually at the place where the iPhone is and the iPads are being manufactured at Foxconn, which is a manufacturing facility with 200,000 workers, actually. We have observed a very interesting phenomenon, that everywhere we build, there is this tremendous layman's interest. In a recent opening in France, 700 people showed up for the opening ceremony. Just think about this. 700 people show up for the opening of a wastewater treatment plant. So this is real. And we believe it's because what we do is actually creates a fascination that it is possible to take that which has been despised and excluded and shunned and shamed of, and we bring it to awareness, first of all, bring it to the light, and we can actually take ownership and responsibility of our waste, and we can close the water cycle in a way that is actually beautiful and lovable, if you want. So with that, I would like to share with you a little study that we made. So we figured, okay, this is the future, obviously. What does it look like when we really put it in a really, really dense city? So we picked Manhattan, the corner of 8th Avenue and 26th, just because my son rented an apartment 2 blocks away. This happens to be a parking lot, and we took a design that serves 75,000 people, the design that we had. So it was really more of an architectural exercise. And this is what it looks like. So we have 2 trains, which is typical to do in the industry. And in the middle, maybe you can make it out, there are all the mechanical rooms hidden from the street. The same way the loading dock would be hidden for a supermarket that's in the middle of the city. That place is not very nice either, if you ever walked into one. So the same approach can be had here. And the reactors would be arranged in a staggering manner, spatially interesting. And of course, if you're in the city, you might as well have an observation desk with an elevator, and with the plants on the top. And maybe you can make it a little ramp as it goes up, in the series of hanging gardens. And of course, you have to enclose it for wintertime. And voila, you have the new genre. These are facilities that you wouldn't call any longer wastewater treatment plants. These are water reclamation gardens or water renewal gardens, where we treat the water not only in the sense of biology and chemistry, but also in the realms of the pristine images that we evoke together at the beginning of this speech. Thank you.